Our topic is the analysis of housing price. My name is Shuning Liu.
And my name is Li Yuanqing. We all come from the Department of Economics.
We're going to talk about this topic is because during 2008 global financial crisis, many countries' real estate market got a huge hit. Housing price index is one of the most important economic index to evaluate domestic economy. So our paper is based on 4 key factor theory. All the data are divided 4 groups, and the most significant variables will be picked into the final model with considering of multiple linearity among the diverse variables. The 4 groups are economic group, demographic group, interest rate group, and government policy group. This is the interface of our app. So the customers could put data into the in the middle circle button, and we will give the result of the relationship of between the response variable with each different predictors. And we also provide 3 models, which is linear model, polynomial model, and log function model for customer to choose. If the customer have specific value for the predictors, we also can do prediction for the house pricing index. The first variable is GDP, which has positive with the house price, since the high GDP makes people have a high salary, which increase demand of the house, which increase the demand of house. The red plot is regressed by linear model combined with the split model. We can see the split model is better because the R-square is about 0.95, which is higher than the linear model. The next variable is unemployment rate. The house demand goes down with employment increasing. We do the same process for employment rate, but there are some problems with that because the predictors correspond to several response variables. As for the producer price index, the PPI has positive impact on the house price, similar to inflation. With the other goods pricing increase, the house pricing is increasing too. The result shows the polynomial model and split model are same on the R-square. The next variable is customer price index, which is similar to PPI, are included in the economic factors to find out more significant variables. The CPI's R-square is about 0.98 from the polynomial model and 0.99 from the split model. As for the private non-residential fixed investment, which is part of real estate, so fixed income increasing with the real estate become popular. And the R-square from 3 model are similar. SP 500 index is the interest ratio of income, which will make people have more money, and they are willing to pay a high price with the same house. Same as population growth rate. The age of population growth rate is unclear. Normally, the house price raises when the population growth rate increasing. However, the people who age between 20 to 40 are actually demand for a house. From the plot, the relation between the house price and population growth rate are negative because the people's age do not require the house yet. The last variable is the gross domestic income subsidies, which would increase the house price is because government subsidy increase the income of individuals. We only use the linear model since the trains of 2 variables are linear relationship.
To get our final model, firstly, we would like to plug all the variables into one multiple linear regression model. From the regression result, we can see that all the variables are significant. Then we will do variable selections to narrow down our original model. By using AIC stepwise, we can remove GDI from the whole model. and we can get the regression result by the rest 7 variables, which are GDP, PPI, CPI, PNFI, PGR, UNE, and SP. Then we'll do multicollinearity check. From the result, we can see that there are some variables have extremely high VIF values. We will remove variables with VIF values higher than 10. There are 4 variables left, which is PPI, PGR, UNE, and SP. The result of final model 2 with these 4 variables show that they are significant and we can use this model. However, there are still one thing we should check, its residual plot. The result of residuals versus fitted values shows a clear trend, which is bad news for us. So we need to figure out a way to fix this problem. Then we try log transformations. We can remove GDR from our model after using log AIC selections. Then we also do multicollinearity check after the transformations. There are left 4 variables, which are PPR, PGR, UNE, and SP. But the result of residual plot is even worse, so we need to find another way out. After this, we find out that we can combine polynomial model with linear regression model. The reason why we do this is because when we do simple regression between housing price and PPI, we find out that their relationship is more fitted in the polynomial model. So we add PPI squared to the model. And the ANOVA shows that it's a better model with PPI squared. When we keep adding third power of PPI, result is not satisfied. So we get our final model 3, which is regression by 5 variables, PPI, PPI squared, PGR, UNE, and SP. The residual plot also improved a lot. According to different data sets, customers can choose different ways to transform their model between linear final model, log function final model, and the polynomial final model. Because our product is aiming to give prediction to our clients about housing price, so we do prediction ourselves using all medium data as our test data. And there's our fitted value, 162. And also, there is its prediction intervals. We also do diagnostic tests, and there are no abnormal data, no high leverage data, no high influential data, and the Cook's distance is fine. Even though we can see that there are some odd points on the plot of Cook's distance, but the maximum value is 0.1, so there is nothing to worry about. Here's our conclusion. From our final model, we can conclude that there are 4 main factors can drive real estate price. There are producer price index, unemployment rate, S&P 500 index, population growth rate. Our app is aiming at people who are willing to invest in the real estate market this year, and we will predict the general house price index this year compared to the 1991. Our model will be updated every half of the year in case of other new factors influencing the house price index. For example, new policy to real estate market may cause new shock. That's why we need to be cautious about new factors. Also, there's still one thing we can improve. The advanced model could be used to explain relationship between unemployment rate and house price index. That's a brief view about our project. Thank you very much.